My name is Gry Bælum Nielsen. I'm Director of Sales and Marketing in Odeon AS. Here is a model of a theater in which I will create a grid, a receiver grid. And you can see the theater is cylindrical, and if I do toggle, you can see these are the audience area where I will define the grid. So I go to the define grid option, and on the left side we have all the surfaces that are not vertical, and we can go through them, pull it out, to find the audience areas. You can see down here we have one. I can also in this one press the auto to select the areas that Odeon will calculate as audience area. And this is kind of a nice one, but I think maybe the reflector is not an audience area, so I'll put that back in the stack of surfaces. So now the audience look like this. It's very dense grid here with half a meter between audiences. I can also see I just want 1 meter between them. Press here, and it is defined as 1.2 meters above the floor. In the defined grid, you also set the desired late reflection density for all the receiver points in the grid. In the other fan in here, set manually scaled grid, you can define the parameters in which scale you want to see them. But I will get back to that later. Now I've defined the grid. I go to the job list. I have already a receiver defined in the middle. So I'll use that and say receivers should look at this source. Sorry, it's a source. Then I'll turn on the grid and do a calculation. Ray tracing and processing. This will take 8 minutes. Okay, a few seconds before the calculation stops, I would like to show you the direct sound, which you can get instantly. Also a grid calculation, but without the room included. This is normally used for loudspeakers to see how sound is distributed from these. The grid is finished with the calculation, and we press here to see the grid. Make it big, and sometimes this happens that we get a black grid result for some parameters, which is not very interesting to look at. So this is why we want to define which range we want to be in. If we, for example, are interested in the STI calculation, we can go with the numbers. 1 is forward and 4 is backward, and 2 or 3 are jumping around, and we can see that STI is around 0.5 to 0.9, and this scale is out of range. So we go to the defined grid again, find the STI. Value is not within range, that's right. So we say it should maximum be 1, and go down to 0.4. That might be alright. So we close that and see. Now we can see all the parameters here. But maybe we are not satisfied with the coloring or something like that, and or the the scale out here, the size of steps, and we can go to option, program setup, grid color, to say, okay, we want maybe a little more steps in the scales. Maybe we want to invert the colors because we think that is nice. We can exclude grids which are not calculated, for example, if they're inside a column or a box and are not interesting. In this case, this might not be so interesting. There's different coloration also available. Yeah, we'll try that. So we'll open the grid again. So now we have smaller steps. There are other things you can do with the grid. You can see that in the 3D grid toolbar. For example, this one, draw geometry first. If there's a lot of geometry on top of the grid, it's maybe easier to see it that way. We can, if we are interested in one particular precision, we can define a receiver, and you do that by pressing Shift and R, and then a receiver is added to the receiver list. You can see that in here. So before I finish, I will just tell you that there are some different statistical options which you can analyze in the distribution graph. You can see different fractals down here. Also in this option, and you can press Ctrl A and you can get the parameters out and use them for Excel. So that's all for now. I hope you learned something. Goodbye.